Hey guys, how are you all? Hey guys, hello, कैसे हैं सब लोग? Well, first of all, I welcome you all back to Vedantu's JEE channel, and specifically a shout out to people who are moving from 11th standard to 12th standard. That means what? I'm talking about people who are targeting JEE 2021. Yes, I want a yo from all of you in the chat box who are going to write the examination of JEE 2021. That means next year. Almost by this time, you'll be done with your JEE examination. Okay. So, guys, you know that at Vedantu's JEE channel, we have exclusively started the different series for students who are passing out right now, moving from school, and they are going to go for their engineering entrance examination. So that is a 2020 series which is already going on. For students who are moving from 10th to 11th standard, we have started a series separately for them. And this particular session is for people who are moving from 10th to from 11th to 12th standard. Okay, so the series has already started. In the previous week, I have taken sessions on electrostatics, which is the very first chapter of 12th standard. Yes, you are aware about that. So more sessions are happening in that chapter, don't worry. The first two sessions dedicated, as you can see on the screen, on Coulomb's law and the basic understanding of electric field. And today's session is about MCQ. Yeah, I'm sure you are aware about the timetable. 2 days in a week we are going to cover the theory, and one day we are going to solve MCQs, only and only exclusively solving MCQ based upon the previous two sessions which were done. Okay, so today's session, no theory will be taught, no theory will be learned, only and only solely and solely problem solving session. Okay, guys, I'm sure you guys are going to enjoy the problems that we are discussing. Okay, do try to solve the questions along with me, and after the session, if you don't understand, watch the session once again and do ask your doubts in the comment section. And there will obviously be a homework question for all of you. Do post the answer of that in the comment section by the end of this video, by the time you're done watching it. Okay, so guys, there are a lot of information that I want to share with you all. Let me first start off with my introduction for people who are here in the channel for the first time. Guys, people who are new, this is me, your Suri Sir, but mostly known as Mugambo. Yes, I'm known as Mugambo because all my students, when they crack the examination, whichever exam they are targeting, Mugambo khush hota hai. Okay, and also when you'll be solving the question, yes, Mugambo khush hota hai. Okay, guys. So what else is the information that I want to share with you? For people who are targeting the examination of JEE 2021, you know that during this lockdown, Vedantu's app and the entire content, including video lectures, including all the study material and various tests, everything is available free of cost for all the students out there. The entire motive is that even when we are locked down inside our houses, the learning won't stop. So, guys, if you are a JEE 2021 aspirant and you want to continue your preparation of JEE, then all you have to do is go to your Play Store. Yes, in your cell phone, download the app, do a few steps of registration, and enroll for free for this course, because you are going to get all the classes live by all your master teachers, including humongous number of tests that you can appear for. And you know that on YouTube, not a lot of doubts can be solved, but all your doubts get solved when you are on Vedantu's platform. Okay, guys, I'm sure I've stated already enough reasons for you to go and download the app and register for the course and start attending the lectures on the Vedantu platform. Okay, so guys, it's a very important information. But apart from that, if you are coming on the YouTube channel for the first time, do subscribe to the channel as well. Reason being, everything which is related to your JEE preparation is happening on this channel. We do a lot of teaching for all the concepts related to your JEE preparation. We do a lot of motivational session, and this one is an MCQ session. Okay, guys, so subscribe to the channel. Also share with your friends. Okay, if you think that it could be a helpful thing for them. Okay, so guys, let's directly hop on to the problem solving. The very first question that you see here says that a total charge capital Q is broken into two parts, Q1 and Q2, and they are placed at a distance r from each other. The maximum force of repulsion between them occur when? So when it is going to happen? For that, we must first look at the options here. It says that different values of Q are there, and that simply means Q1 and Q2 are not fixed value. We have to rather find when the force between Q1 and Q2 is going to be maximum. So guys, say that one of the charge is Q1 at a distance r from it, another charge Q2 is placed. They are either attracting or repelling each other. I would rather say they are going to repel each other because capital Q has been broken, so the charge polarity remains the same. So they are going to repel each other. So when they are repelling, we want the force of repulsion between them, which is an action reaction force. We want it to be maximum. So in order to find that, let me assume that Q1 is charge small q, the total charge is capital Q. So certainly the other charge Q2 becomes capital Q minus small q. Okay. And now I'll try to write down the expression of force, which is K Q1 Q2 by R square. Okay. Now what? Let me express capital Q1 and Q2 in terms of small q. So this is how the expression looks like now. Let's multiply the small q inside. So this becomes q into small q minus q square divided by r square. This is the expression of force. Now, whenever we speak about maximum values of any quantity or minimum value of any quantity, we know that we need to differentiate. So because small q is variable, that will be the factor with respect to which force will be differentiated and obviously will be equated to 0. Okay. So let's go ahead and try to find that. So if I want to write df by dq, small k and r square. K is basically 1 upon 4 pi epsilon naught, and r square, the gap between the charges is not changing, that's constant. And if we look at this particular bracket, capital Q constant, small q is variable. So if I differentiate, capital Q will remain as it is, small q will become 1 after differentiation. Okay, it will not become 1, rather the differentiation will be 1. Q square on differentiating will give you 2q, and this value should be equal to 0. So this left hand side becomes 0 only when this bracket becomes 0. Means I can say that capital Q minus 2q is equal to 0, which says that simply tells us that small q should be equal to q by 2. And what is small q, by the way? It is q1. So that means q1 is equal to q2. And what is q2? Q2 is equal to, so Q1 has come out to be Q by 2, and Q2 is equal to capital Q minus Q1, that is also going to be the same value, Q by 2. That means what? If you want the force between the two charges which are being created by breaking this charge into two parts to be maximum, then the two charges must be divided in such a way that their magnitudes are equal and equal to half of the value of the parent charge. Okay, awesome. Next one. This says that three charges, capital Q, small q, and another capital Q, they are placed respectively at distance 0, d by 2, and d from the origin on the x-axis. So if the net force experienced by capital Q charge, which is placed at x equal to 0, is 0, then the value of small q should be how much? So let me arrange them, all the three charges on x-axis. So say this is O, this is A, and this is B, obviously at a distance d by 2 and further at distance d. So this is your charge Q, this is small q, and this is capital Q. This gap is d by 2, this gap is also d by 2. So the charge which is placed over here, it is said that it is going to experience, zero force. Okay. So assuming that right now we don't know the polarity, assuming that small q and capital Q both are also positively charged, so they are going to repel this charge. That means what? It is going to experience a force, say Fa from small q charge and Fb from capital Q charge, which is placed at B. So these two forces should add up to become 0. Okay, so I'm going to write that the forces value and I'll equate it to 0 because that's what the question is telling us to do. So I say that Fa plus Fb, not magnitude but vectorially, should be equal to 0. So let me write that. So Fa is the force which is applied by this charge, which is at a distance d by 2. So So it is K capital Q small q by d by 2 square, which is basically d square by 4. So obviously 4 will come in numerator. After that, F of force which is applied by B, and the charge which is placed at B will be K Q1 Q2 by R square, and R is equal to d by 2 plus d by 2, that is d, and square that, and this value should be equal to 0. Okay, because I have considered the direction to be same, that's why I have not written minus over there for both of them, or minus I cap I have not written. Okay, if you want you can write down minus I cap as well, go ahead, no problem with that. Okay, so now what, I'll take one of them, one of the expression to the right hand side, and I'll try to simplify it further. So when I do that, guys, I have 4k capital Q small q by d square equal to k capital Q by d square. So you can see that d square gets cancelled, and obviously a minus sign will come here. K and Q gets cancelled. So I have 4Q equal to minus capital Q. So small q comes out to be minus q by 4. I'm sure many of you got the answer. Yep, very good, very good. So guys, correct answer is option A. Okay, going back to my favorite color for writing it over here. Okay, so answer is option A, minus q by 4. Okay guys, next one. Three identical charges are placed at the vertices of an equilateral triangle. The force experienced by each charge, if small k is 1 upon 4 pi epsilon naught, is going to be how much? So say that your charge is being placed, color didn't change, so let me change the color now. Okay, so say one charge is here, other one is here, and the other one is here. All of them are equal in magnitude. So, and like charges as well, so that's why they will repel each other. So we want to find out the force which is experienced by each charge at this moment. So I'm going to call this as A, this as B, and this as C. You know that all the angles are 60-degree for an equilateral triangle. So that's why we can say that A will repel this charge by some force F, and by the same force of same magnitude, B will also repel this charge which is placed at C. Okay, let's say that the charge values are small q. Okay guys, so if this angle is 60-degree, then this angle has to be equal to 60-degree, and we are interested in finding the net force which is experienced by each charge. So if I want to find out the net force which is experienced by the charge placed at C, okay, which you know will be found by using parallelogram law of vector addition like this. Okay, so Fr is going to be a square plus b square plus 2ab cos theta, like that. Okay, so let me just go back to writing it. So a square plus b square plus 2ab cos 60-degree. This is Fr square. So I have 2f square plus 2f square, and cos 60 is half. So that gets cancelled. So I have 3f square as Fr square. That means Fr comes out to be root 3f. Okay. But what is F? What is F? F is basically one of the forces. And if I consider the gap, because as per the option, it looks like the gap has to be considered to be R. So let me write capital F, and that is going to be K Q1 Q2 by R square, or you can say it is K Q square by R square. So if I put the value of F back here, I get the value of Fr as root 3 K Q square by R square, which means the correct answer is option C. Okay, root 3 times KQ square by R square. This is our correct answer. Okay, guys, very nice. Next one, as you can see it in the diagram, is going to be a question with 4 charges which are placed on the corners. So it says that 4 charges of equal magnitude minus q are being placed on the corners of the square. Okay, and a small q charge is placed at the center. So if the system is in equilibrium, then the value of small q should be how much? So guys, say there is a charge minus q which is placed at B. Okay. So initially, uh, let me say that what if this small q charge was not here at the center? Then, if I consider the side length of the square to be say d, and this is also d, and the diagonal is going to be root 2d, okay, then all the charges which were placed on the other corners of the square will try to repel this charge. So say the force which is applied by charge from C and charge from A, they are equal, and say those forces are F. I'm writing those forces. F because of A, F because of C is going to be K Q square. I'm writing the magnitude, okay? K Q square by D square, okay? And the force which is applied by charge which is placed at D will be K Q square by the gap between these two. D and B, they are separated by a gap root 2D. Yeah, you know how to do that simple calculation by Pythagoras theorem. So if this is D and this is D, the hypotenuse is root 2D. Squaring that will give you 2D square. Okay, guys. So if I call these two forces as F, then FD is basically F by 2. Okay. Now, before I write the force because of D, let me tell you that I can talk about the resultant force of A and C force. Means what? If I choose these two forces, I can find out their resultant. And you know that because they are inclined equally at an angle of 90 degree and of equal magnitude also, the resultant is going to be root 2 times F or F root 2. Okay. So this F root 2 is there and F by 2 is also there. I hope that is clear to all of you. F root 2 is basically the resultant of F and F. Okay, I should rather say that F root 2 is basically the resultant of FA plus FC. This is how F root 2 is coming. And F by 2 is in the same direction, so that's why it is added. Okay, that means what? The overall resultant force is F root 2 plus 1 by 2, or you can say it is F by 2 and in bracket 2 root 2 plus 1. That's basically your FR. Okay, guys. But how do I write F, by the way? Let's write it on the next slide. So F is basically K. Let's go back. Q1, Q2 by D square. We have already written it here. Okay. So K Q square by D square is your F. And your resultant force is basically F by 2, 1 plus 2 root 2 in terms of option if I see. So let's put the expression of this force here. Okay, so what do I get? Fr comes out to be K Q square by 2D square 1 plus 2 root 2. Okay, so what have I got, by the way? I've got the net force which is applied by all the three charges which are placed on the corners. But we want this charge which is placed over here at B to be in equilibrium. That means what, guys? This charge will be in equilibrium only when this small q charge is going to attract it in this opposite direction. And when it is going to attract, it has to apply the same magnitude of force. Okay, that means what? If these are the charges which are applying this force in this manner, then the question is asking the value of small q. So we are sure that these charges which are placed on the corners are negative charges. So definitely the charge which is placed at the center has to be positive charge in order to keep the system in equilibrium. So suddenly that realization should be there that the answer is not going to be option A and option C. These two cannot be the answer because they are telling us that the charge small q is negative. The small q charge is not negative, it's going to be positive because already negative charges are placed on the corners. Okay, guys. So let's quickly find out the value of small q by equating the force which is being applied by this force this charge, which is actually at a distance half of root 2d. Okay, so if I find out the distance of that small q charge, that small q charge is at a distance root 2 d by 2, which is basically d by root 2. Okay, just a second, guys. Yeah, so this becomes d by root 2. So now what I'm going to do, I'm going to equate the force which is applied by that small q charge over here. So that is k capital Q small q by this distance square, which is d square by 2. So the 2 goes in numerator. Okay, guys. Now what? It's very simple, just to simplify and find out the value of small q. So k gets cancelled, 1q gets cancelled, d square gets cancelled for sure. So k, q, and d square get cancelled. What you are left with is 2, which will come here. So, guys, writing it here, q comes out to be capital Q by this 2 and this 2 multiply q by 4 and 1 plus 2 root 2. I hope that's understandable. This 2 has come here multiplied with this 2, and the answer looks like this, which, as I said, C is not the answer, A is not the answer. This looks like the correct answer is going to be option B. Okay, guys, I hope you got that. Good question. Yeah, awesome. Next one, guys. 3-point charges are placed on a circumference. Let's increase the speed a bit. Okay, I know that some of you are finding the process to be slow. Let's try to speed up a bit. I'm also feeling that way. So 3-point charges are placed on the circumference of this circle of radius d. Okay, so radius is d, not the diameter. Okay, so the electric field along x-axis at the center of the circle is going to be how much? So guys, you can see that this 2q and this minus 2q are basically placed diametrically opposite to each other. So if I write their electric fields are going to be at the center, obviously. At the center, their electric field, if I write, it's going to be k 2q by say d square. Okay, both of them have the electric fields of equal magnitude. But if I write the electric field, also let me give them a name as A and B, and this one is C. So this is electric field of A and electric field of B. Okay, but if I try to write the electric field of C, then that's going to be K 4Q by D square, which is basically double that value. So if you call the electric field of these two as E, then the electric field of EC is 2 times of E. Okay, now guys, the important part here, pay attention to this. So if you say that because of A, the electric field is going to be, because it is positive charge, and I hope you guys remember this, because of positive charge, the electric field lines go away, and because of negative charge, the field lines will always terminate towards the charge. Okay, so if I draw the field direction at O, because of A, the electric field is going to come in this direction. You can see that, yeah, and because of B also, the electric field is going to be in the same direction. That means this is the direction of electric field because of A and electric field because of B. So let me do one thing, let me draw it here. Okay, so this is the direction where electric field of A and electric field of electric field of B are going. Okay, this is the zoom direction of this one, and this is the negative charge, so this will have its own electric field in this direction. Okay, that means if I zoom it, this is the electric field of C. Okay, but guys, electric field of A and B, if I now draw it properly, electric field of, let me label them properly, in fact, electric field of A and EB, they are equal, so that value is basically 2E, and electric field of C is already 2E. So these two electric fields are basically equal and are inclined at an angle of 60 degree. So their resultant is going to be basically what? If this is 2E and this is 2E, you know that the resultant is going to be root 3 times the value of 2E, and that's what we are supposed to find out, guys. Okay, so if we are finding the resultant electric field, which is root 3 times the net electric field, is root 3 times the electric field individually. You can simply apply the parallelograms law of vector addition here. By the way, I did that once earlier for all of you guys here. Let me just show it to you. Yeah, this is where we did that. Okay, two vectors were inclined at 60 degree, so the resultant came out to be root 3 times the resultant came out to be root 3 times the individual force. Okay, so same thing is happening now. You can see that two vectors are inclined at an angle 60 degrees, so root 3 times the individual value. So now what, guys? Root 3 into 2 into electric field, that is K, because of any one of them, this or this, is K into 2Q by D square. That means, guys, if I write the expression in terms of not K but 1 upon 4 pi epsilon naught, so I have the value as 4 root 3 into 1 upon 4 pi epsilon naught into Q by D square. So you can see that 4 and 4 get cancelled. I'm left with Q root 3 by pi epsilon naught D square. Do I have an option like that? Q root 3 pi epsilon naught D square. That means option C is our correct answer, guys. Okay, another good question. Yeah, so that's your resultant electric field at O, at the center. Okay, this is your center. Moving on. Now this question says that you have 5-point charges. Each are placed at 5 vertices of regular hexagon. So hexagon you can see, and say these are the 5 charges which are being placed here. Okay, and all are like charges, but the hexagon has side 2a. Okay, the side length is 2a, and you know that hexagon with center, if I consider this triangle, it's going to be an equilateral triangle. So guys, the question is asking what is the magnitude of the net electric field at the center of the hexagon. Now, interesting thing to see here is that if I look at charge F and charge C, they both are basically trying to send electric field away from them, and both of them will have equal and opposite electric field. So EF will cancel EC. Similarly, electric field of A will be cancelled by electric field of B. So EF and EC get cancelled, EA and ED get cancelled. Okay. So what has happened so far? The electric field EF got cancelled with EC, EA got cancelled with ED. So what are you left with now? So you are left with only one charge, and that charge is basically placed at B. So what you are interested in is basically the electric field of one charge. By the way, you can also see it this way, that if you will place a charge at E as well, then the net electric field at the center has to become 0. So you can find out the electric field only because of that. Okay. So now I'm finding the electric field because of B. That's going to be a very simple task now. Electric field that is because of B, it is also the resultant electric field. ER is basically the resultant electric field. ER. Okay. I'm writing it as K Q by R square, and R is going to be the gap between center and B, that is 2A. So 2A square. Okay, guys. So K is 1 upon 4 pi epsilon naught into Q by 4A square. That means it is Q divided by 16 pi epsilon naught A square. That's the electric field resultant value at the center. Okay, so at the center it is Q upon 16 pi epsilon naught A square. So obviously A, C and D are not the correct answer. Correct answer is option B. Okay, awesome, guys. Now this one. This question says that there is a point mass, means this is a very small mass, having a charge Q on it, is connected by a massless spring of natural length L. Okay, that means initially the natural length is there, and initially the spring is in natural length, and if a horizontal uniform electric field is switched on as shown in the figure, then the maximum separation between the point mass and the wall is going to be how much? So basically this electric field is going to behave like an external field, and it's going to apply an external force in this direction, that is QE, and it's going to take it in such a way that whatever will be the work done by this external force, it's going to get stored by the spring. The work done will be stored by the spring in the form of the potential energy. So say it's going to take it further by a distance x away. So the amount of potential energy stored in the spring is basically because of the work done by the external force, and that external force is basically your electrostatic force, QE. So if I write the work done, that work done will be equal to F into x and will be stored as half kx square. Okay, so if I write this, you can see that x is getting cancelled, and this tells me that F is going to be k by 2x, or x is going to be 2f by k. Okay, I'm just finding x as of now. That's not our final answer. So what is the force? Force is QE divided by k multiplied by 2 as well. So 2 QE by k is the displacement of the mass from the initial position. But the question is asking not x, but this entire distance from the wall. So the maximum distance, this value came out to be the maximum value of x, and the d value is going to be L plus x. That means what? C value may will be adding L as well to give you the value of d max. Okay, that means if you look at the options, you can easily see that option A, L plus 2 QE by K is our correct answer. Okay, guys, very simple. Law of conservation of energy, or you can say work energy theorem, is what we have used. I've said this n number of times earlier as well. The concepts that you have learned in mechanics and 11th standard are very important. They will be utilized every now and then. So if you are not very comfortable with them, do go back and revise your chapters like vectors, calculus, laws of motion, work power energy, center of mass relation, and law of conservation of momentum. Okay, guys? Cool. Now, guys, this brings us to the homework question. Read the question for all of you. Three charges Q1, Q2, and small q are placed on a straight line such that small q is somewhere in between Q1 and Q2. If the system of the charge is in equilibrium, then what should be the magnitude of and the sign of this charge small q? Is that what you have to find out? Okay, guys, your options are there. This is your homework question. So what you will do, you will obviously try the question by yourself, and what will you do after that? Once you are done with your question, post your option that you think you have got as the answer in the comment section. Okay, do tell me, do let me know which option you got the answer as. Okay, guys, and I will respond with the correct answer. Okay, also if you are finding the questions which we have solved to be relatively challenging, do watch the session once again and try to solve the questions along with me while watching this video. Okay, guys, so people have been asking a lot many times that sir, how to get more assignments, how to get the study material, and how about the daily updates. So guys, one stop solution for all of you is the telegram group for the Vedantu's JEE channel over here. Okay, yep. So all you have to do is follow the link which is available in the description, by the way. So follow the link, come to the Telegram group. You are going to get the assignments related to each and every session that you see, and important study materials and daily updates of what is happening on the channel is given over there. Okay. So guys, if you liked solving the problems with me, do hit that like button, share with your friends if you think it is going to be helpful for them as well. And more importantly, do subscribe to the channel. Why? Not for Vedantu, but for yourself, because if you subscribe to the channel, you are not going to miss out on any of the session which is happening, not just academic but motivational session as well. Okay, so guys, I hope you enjoyed the session. Keep on coming, do subscribe to the channel, saying this once again, and don't forget to enjoy physics, and in this difficult time, stay safe, stay at your home, and take care of yourself as well as of your family. Hey guys, see you very soon. Till then, bye bye. Take care.